Hello, my dear students. Welcome to a new episode of Science. Today we will talk about volcanoes. What are volcanoes, or where are volcanoes found? Volcanoes form on land and on the ocean floor as well. So we can find volcanoes on land, in the continents, and on the ocean floor. So this is in the ocean. A volcano is an opening in Earth's crust. A volcano is an opening in Earth's crust. Volcanoes are only located in certain places on Earth's surface. Let's know about them. As you know that Earth's crust is broken up into a number of moving plates. Yes, these black lines are the boundaries of the plates that cover the Earth's crust, or this is the Earth's crust itself. It is divided into several plates. Most volcanoes are found where these plates meet. So most volcanoes are found at the boundaries of these plates. For example, a circle of volcanoes called the Ring of Fire surrounds the Pacific Ocean. As you can see, this is the plate lying under the Pacific Ocean. It's called the tectonic plates. This plate, on the boundaries, there is a series of volcanoes known as the Ring of Fire. The Ring of Fire follows the boundaries of the plates that meet around the Pacific Ocean. Volcanoes are more likely to erupt at plate boundaries than anywhere else on Earth, so they are more likely to erupt at the plate boundaries. An eruption is an outpouring of melted rock, ash, and gases, or a combination of these, as you can see. An eruption of the volcano is an outpouring of melted rocks, ash, gases, or a combination of all of them. And these are the components, or this is a cross-section of a volcano. As you can see, deep in the bottom, this is called magma chamber. Magma chamber. Then we have the main vent and we have side vents. Side vents. This is where the magma is pushed to the outside. Then we have the crater, and we will know what is the meaning of a crater. So, however, volcanoes do not erupt all the time at all plate boundaries. What makes some plate boundaries likely places for volcanoes to erupt? Why? Let's see. After collecting data about the directions in which the plates moved, scientists concluded that volcanoes tend to erupt where one plate is pushed under another one. As you can see here, we have two plates. One of them is pushed under the other one. Plates melt under great heat and pressure as they are pushed down into the mantle. This forms magma, which pools in a chamber beneath Earth's crust. So when the plate is pushed under another one, it is pushed into magma. There is a great pressure and heat, so it melts and makes a pool of magma. The magma may rest quietly for hundreds or thousands of years. Sometimes a crack forms above the chamber, and the pressure in the chamber grows too great to be held in by the rock above it. So in this case, then the magma rushes upward the Earth's surface. All volcanoes have at least one vent or opening to release the magma. Once magma reaches Earth's surface, it is called lava. So when you can see the lava with your own eyes on the top of the volcano, this is lava, not magma. Magma is deep inside the Earth's layer. Lava, ashes, and gases erupt through vents as well. Over time, a cup-shaped depression like this one here, a cup-shaped depression may form around the vent. This depression is called a crater, like this one. Most craters are found at the top of a volcanic mountain. Most craters are found at the top of a volcanic mountain. Sometimes the magma chamber beneath a volcano is emptied from inside. The magma chamber deep in Earth, beneath the volcano, it becomes emptied from the magma. The volcano may then collapse inside itself like this one right here. The hole that forms is called a caldera. How do volcanoes build land? Let's see. Sometimes the magma cools and hardens before it reaches the surface. Then we have many components right here, or many structures. The first one is called a dike. Dike or dam forms when magma hardens in vertical or nearly vertical cracks. So when the magma hardens in vertical or nearly vertical cracks, this is called dike. The second one is named sill, threshold, sill. Sill forms when magma hardens between horizontal layers of rocks. A sill or threshold forms when magma hardens between horizontal layers of rock. Dikes and sills can be large or small, but sometimes the magma is pushed into a sill, does not spread horizontally. So in this case, instead, it pushes upward and forms a dome shape called laccolith. When a laccolith forms, it may rise the rock layer above it. We will see all of them now. The largest and the deepest of all underground magma formations, this is the fourth one, they are batholith. A batholith is a huge and irregularly shaped form of underground magma. It reaches deep into the crust. And here you can see all of them. Dike, this is a vertical hardening of magma, and sill, which is horizontal. And we have laccolith when the magma is pushed into a sill, but it does not go through the layers. It pushes the layer above it. And the batholith is the largest of all the formations. Okay, when lava comes out of a vent, it is a liquid. Lava forms solid rock as it hardens when it cools off. Over thousands of years, new lava can increase the height of a volcano. Yes, because it hardens as rocks and forms a volcanic mountain. This is new land that the volcano has built. So what about the categories of volcanoes? We have three categories: active volcano, dormant volcano, and a dead or extinct volcano. Let's see. What's an active volcano? It is currently erupting or has recently erupted. A dormant volcano is a volcano does not erupt for some time. What about the dead or extinct volcano? It's a volcano that stops erupting. What about the active volcanoes? They are divided again. Active volcanoes differ in how they form and in the shapes of the mountains they build into three types, which are shield volcano, cinder-cone volcano, and the composite volcano. Let's see what about each one of them. Number one, shield volcano. From its name, it is shield, so it must be broad or wide. Shield volcanoes are built by thinner fluid lava that spread over a large area. As you can see, the lava is in thin layers that are spread over a large area. These mountains have a broad base and a gently sloping sides. As you can see, it has broad base and a gently sloping sides. This is one in nature. Then the second one is the cinder-cone volcano. Cinder-cone volcanoes are built by thick lava that is thrown high into the air, as you can see. Then it falls as chunks or pieces of cinders, which are rocks on fire. These mountains form as a cone shape with a narrow base and steep sides. Narrow base and steep sides. They are steeper than the sides of the shield volcano. The third type of active volcanoes are composite volcanoes. Composite volcanoes are built in layers of ash and cinders, sandwiched between layers of hardened lava. As you can see, the shape on one side of a cone formed by a composite volcano usually looks the same as the shape on the opposite side. So from all the sides, they look the same. These are the three types of volcanoes: the shield volcano, broad base and gently sloping sides; the cinder-cone volcano, narrow base and more steeper sides; and this is the composite volcano. How do volcanoes build islands? This is the Hawaiian Islands. We will talk about them and how they are formed. The Hawaiian Islands, they are an island chain or a line of volcanic mountains, as you can see. Okay, how did these islands form? Scientists know that the Hawaiian Islands rest on a slowly moving tectonic plates a slowly moving tectonic plates. As it moves, these plates, they are moving all the time. As it moves, the plate passes over a stationary pool of magma called a hot spot. As these plates move, the plate passes over a stationary, a fixed pool of magma, which is named a hot spot. Over millions of years, lava erupting from the hot spot formed a mountain. Eventually, the mountain grew taller than the ocean surface, so it became a volcanic island. Yes, as the plate moved, it holds the volcanic island. That island moved away with the plate from the hot spot, and a new island began to form again. Look at this picture. Imagine that this is the pool of magma. This is the hot spot. It is fixed, but the tectonic plate is moving. So in this case, when the tectonic plate moves, it holds or it carries the mountain, which became a volcanic island, away from the hot spot. Then a new one forms. And here are the Hawaiian Islands. This is the tectonic plate that is moving. And this is the hot spot, which is fixed in its place. It's stationary. It does not move with the tectonic plate. So the oldest island here is Kauai, and the newest one is Hawaii. Okay, then we have another term which is called island arc. An island arc forms in areas where an ocean floor plate is pushed under another ocean floor plate. So we are talking about plates that lie under the ocean's own. As the plate is pushed down, it melts because it is pushed down into the mantle. Magma forms, rises upward, and erupts through the ocean floor. These eruptions form a series of volcanic islands along the plate boundary. We have an example here which are called the Aleutian Islands. Aleutian Islands in Alaska, this is an island arc. When two oceanic plates, one is pushed under the other one, there is a series of eruptions. It forms an island arc. Here we come to the end of our episode of science where we talked about volcanoes. Hope you understood this part. Thank you. See you in the next period, and goodbye.